Kingsnorth is the largest power station operating in the southeast of England. With a total output of 2,000 megawatts, it's been generating power since the early 70s. The turbine hall and the boiler houses stand on what was once a marsh known as Damhead Creek. It was the proximity to London, ready access for fuel supplies, and a plentiful supply of cooling water from the Medway that made this a suitable site for such a large power station. Kingsnorth is different from many other power stations because it's able to burn both oil and coal, or any combination of both. In fact, it's one of the largest dual-fired stations in Europe. Like all our power stations, Kingsnorth doesn't generate electricity exclusively for the surrounding area. It's part of a much wider, highly complex system, supplying electricity directly to the national grid as and when it's needed, for the whole of England and Wales to share. Even when demand is at its peak, the national grid is flexible enough to respond. A network of over 13,500 kilometers of transmission lines, distributing over 50,000 megawatts of electricity. This network links over 70 power stations throughout England and Wales, an industry which has grown to become one of Britain's biggest businesses and one of the largest power systems in the world. Under the government's privatisation proposals, the Central Electricity Generating Board's generating capacity will be divided between two substantial new public companies, called National Power and Power Generation. Both organisations will be among the country's largest companies. The proposals also include a new national grid company responsible for the transmission of electricity in England and Wales. Electricity is generated using different fuels. By far the largest number of power stations are coal-fired, producing around 4/5 of our electricity. Oil and gas turbine stations are only used when necessary because of their operating costs. Hydro and pumped storage stations are very useful for providing small amounts of electricity very quickly. About 15% of all our electricity comes from nuclear-powered stations, operated under very strict safety regulations. Behind all this generating capacity are years of expertise. Ongoing research and development will continue into the best means of meeting a growing demand for electricity. It's an industry changing to meet the future, making sure that electricity is always being generated as economically as demand allows, and being distributed to where it's needed most. Whatever their size or fuel, power stations generate electricity in exactly the same way. Every power station has a number of generator units, each driven by a number of turbines. Hydro and pumped storage stations use water under pressure to drive turbines, but steam is the most common method. The energy of high-pressure steam passing the turbine blades causes the turbine to rotate. The turbines drive the generator, where a magnet or rotor rotates inside a cylinder of copper bars known as a stator, generating electricity. The electrical current of all our power stations is synchronized at 50 cycles a second and transformed into the required voltage for the national grid, either 400,000 or 275,000 volts. Kingsnorth has 4 500-megawatt turbine generator units. Each unit consists of a high-pressure turbine into which steam at 1,000 degrees Fahrenheit is first fed. The steam is then reheated and recycled at a lower pressure into an intermediate and 3 low-pressure turbines. These are linked to a generator producing electricity. The steam is produced in 4 dual-fired boilers, which will soon be equipped with a new type of burner to keep the flue gases as clean as possible. In the early years of operation, the station burned oil, and oil is still regularly used as a backup fuel. It's surprisingly thick and viscous. The 300,000-ton oil storage capacity also supplies nearby grain oil-fired station along a 7-mile underground pipeline. But for some years, coal has been the primary fuel at Kingsnorth, where 140,000 tons of it are burned every week at full load. Coal arrives by sea at the station's Long Reach jetty. It's the only jetty of its kind in a British power station servicing a deep-water berth. Carried by 20,000-ton colliers, the coal is mostly British, although the station is capable of utilising foreign fuel. Each of the latest screw-driven unloading systems empties the colliers at the rate of 1,000 tons an hour. They're also used for fuel trimming of the boats. The coal is carried by conveyor to the storage area, being enlarged to store 955,000 tons of coal. This is enough to keep the station running at full load for several weeks. From here, the coal is fed into the station and ground to a fine powder in pulverizing mills. There are 5 of these mills to each of the 4 boilers. The coal, pulverized to a fine powder, is carried in a stream of hot air to a series of burners in the boiler, where it burns like a jet of gas. Inside the boiler are miles of steel tubing, which absorb the heat and convert extremely pure water into high-pressure steam. This steam is heated even further in a superheater, then passed to the turbines, which in turn drive the generators. When the steam has been condensed, the water is fed back into the boiler. When oil is being used, it's heated to the temperature necessary for efficient combustion. A series of burners then spray the oil under pressure into the boiler furnace. A small amount of grit is the only waste that's produced from burning oil. Coal combustion, however, produces 2 byproducts. 80% of this is known as fly ash. It's removed electrostatically from the flue gases and used by the cement industry. The remaining 20% falls to the bottom of the furnace. This bottom ash is carried in a slurry to lagoons, where it settles and has many uses, such as for road fill. The lagoons themselves have helped not only to preserve, but to dramatically increase the wildlife in the reed beds and mudflats. A warden looks after the nearby reserve that's been created. From the River Medway, 225 million litres of water an hour are pumped into the station when all 4 turbines are running to cool and condense the steam. These rotating screen drums remove fish and any foreign particles. Should the grid fail for any reason, 4 gas turbine backup generating units are installed to power all the auxiliary plant and to supplement supplies to the grid if needed. Every aspect of the station's operation is supervised and monitored from the control room. From here, each of the 4 turbine units can be stopped and started whenever directed by the grid control centre. Around 800 people from the surrounding area work here at Kingsnorth. A whole range of skills and disciplines, keeping the station running smoothly. There are fully equipped workshop and maintenance facilities. In the station's laboratories, a constant check is kept on every aspect of the station's performance. In the administration offices, staff deal with supplies and a whole range of outside services and contractors. This, in turn, benefits many more people in the area whose livelihood depends on Kingsnorth. Over 1 billion units of electricity have been generated here since the station came into operation. Kingsnorth makes an important contribution not only to the local community, but to one of the largest power systems in the world. It's a secure, reliable system, always ready, anytime, every day, to help supply the electricity upon which we all depend.